Welcome Year 10 to Lesson 10 of our video online tutorials. This lesson we're going to be looking at congruent triangles. Now you've done this before, but we're going to have to revise it to go further in this chapter. So let's have a quick look. What is congruency? Well, congruent means exactly the same. And when we're talking triangles, we're talking about triangles that are exactly the same. The symbol you can see in the second row is a symbol to show congruency. It looks like the equals sign, but there's an extra line above or below, so you have 3 lines instead of 2. We can use this symbol in maths to talk about two triangles being exactly the same. That is, that their sides and all their angles are equal. So below you can see that triangle ABC is congruent to triangle DEF, and I've marked in that the sides are equal and that their angles are also equal. But here's the tricky bit. It's pretty easy to compare two triangles that are positioned the same. And you can see I've got two below, triangle ABC and triangle DEF. And they're positioned the same, and therefore you could look at them and think, yep, they could possibly be exactly the same. But in most questions, the triangles are moved, if not repositioned, to make it a bit confusing. And they look like this. You can see triangle ABC and triangle DEF here. To prove that two triangles are congruent, there are 4 tests for congruency. That means that if we can prove that any of these 4 tests are true, then those two triangles are congruent. So let's have a look at the 4 tests for congruency. The first one, if all corresponding sides are equal, then two triangles are congruent. And we call this test side, 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 or SSS. The second test is that if we can prove that 2 pairs of corresponding sides are equal and that the corresponding angles between these sides in each triangle is equal, then the two triangles are congruent. And we call this side angle side, or SAS. Thirdly, if we can prove that 2 pairs of corresponding angles are equal and that 1 pair of corresponding sides are equal within the 2 triangles, then the triangles are congruent. And we call this test angle angle side, or AAS. Lastly, if we have 2 right-angled triangles, we can use the 4th test for congruency. If they are both right-angled triangles, if their hypotenuse are equal, and think of this being the diagonal on the triangle, and 1 other pair of corresponding sides are equal, then we can use the proof right angle hypotenuse side, or RHS, to prove that those two triangles are congruent. So make sure you write this down in your notes, that the 4 tests for congruency are SSS, SAS, AAS, or RHS. The abbreviations will help you understand how to prove. Okay, so these were the steps that I was taught when I was looking at proving that 2 triangles were congruent. The question here has asked us, prove that triangle ABC is congruent to DEF. These are the 5 steps that you need to follow. Please make sure you've written these down in your notes. Number 1. To avoid this being tricky, draw the triangles again so they are in the same position. Number 2. Label in all the information that the question has given you. This might be that their sides are on one side of corresponding sides is already equal, or that one pair of corresponding angles are already equal. It might even be that they are right-angled triangles, but label this information in. 3. Scan the two triangles and the information you've been given to look to see which of the 4 tests will be easiest to use. Is it going to be SSS, SAS, AAS, or RHS? Number 4. The best way to prove triangles are congruent is to try to solve the puzzle in your head first. Scan the 2 pieces of information and see what you are likely to be able to perform. Number 5. When you think that you actually understand and know how to prove that these 2 triangles are equal or congruent, write the proof with all reasoning next to it. Let's have a quick look at an example. Here's a good example of one that might appear in the exam. Triangle ABC is isosceles, with BA equaling BC, and AE is perpendicular to BC, and CD is perpendicular to BA. Prove that these 2 triangles are congruent. So, let's go through our steps. The first thing you'll need to do is draw the 2 triangles separately outside of the diagram they give you. So if I bring this one over, we can see that this is triangle AEB, or ABE. Let's move it down. I'm going to quickly flip it and rotate it so that the triangle looks a little easier to use. And we're done. Over here, I've got triangle CBD, another one that they've asked us to prove is congruent within the question. So I'm going to bring him down as well and reposition it just so that it's easier to look at and easier to understand. Alright, so step 1 done. Step 2. You need to actually look at the information they've given you in the question about these triangles. So let's read the question carefully. Triangle ABC is isosceles. So if we look in the original picture, triangle ABC, now that's the entire triangle in the picture, is isosceles, meaning that BA is equal to BC. So let's look back at our 2 triangles that we've separated, and we can just find those 2 sides. BA is this side. BC is this side. And the question has told us that those 2 sides are equal. So let's grab our little symbols to show that these 2 sides are equal because the question has told us so. Secondly, it's given us one more piece of information. That side AE, and I'll point to it in our new triangles, AE is perpendicular to BC. BC will be over here. And that CD is perpendicular to BA. You can see they've given this information to us already in the diagram. It just means that we've both got right-angled triangles. So, on my 2 new triangles, I'm going to put that information in as well. So we've completed step 1 and 2. We've drawn the triangles separately, and we've put in all the information that the question has given us. Now we need to think in our heads, what is going to be the easiest way to prove that this triangle is congruent to this one? Now instantly my head goes to RHS, to be able to prove that if the 2 triangles are right-angled triangles, and we've been given that, and their hypotenuse is equal, we've been given that, then all I would need is one more corresponding side to complete the proof RHS. Unfortunately, this has not actually given us any more information about the two other pairs of corresponding sides. I've been searching this and I still can't find any piece of information that might tell us that either this side is equal to this side or that this side is equal to this side. So I can't use RHS. Let's have another think. We know that both triangles have angle B in it. That CBD and ABE both have this angle here. We can call that angle B. And if we look here, we can see that angle B in both triangles is equal because both triangles have it. We would call this a common angle. So in my head, quickly, I realise that I've got two pairs of corresponding angles, these two and these two, that are both equal. And I have one pair of corresponding sides, this one and this one, that are also equal. Therefore, my head tells me straight away that I could use the proof AAS, angle, angle, side. So let's have a look at what my working out would be, and we're going to do lots of examples of these in class. You would always start by writing in triangle ABE and triangle CBD, and why don't we copy our little, well, we can't copy our triangles there, but imagine that there would be a little diagram of a triangle before each of these. That would be our first sentence, and then we would look at proving our three things, and in this case it was the angle, angle and side test. Angle ABE, this one here, which we said is a right angle, is equal to angle CBD, also a right angle. So they are both equal to 90 degrees. Now our reasoning for this would be it's given. The question gave it to us, therefore we would simply write given. We can now look at our side. BA, or AB, is equal to BC, these two sides. Now the question also gave us this piece of information. So once we've written it, we would also write in our reasoning that this is given. Now the one thing that we had to search for in this example was our last angle. And we realised that both triangles have angle B. And if both of them have it, therefore it's equal. So I can now write that angle ABE is equal to angle CBD. And if both triangles have it, we would call this a common angle, meaning both triangles have a common sized angle within them. So I've now proven that these two triangles are congruent. Angle, side, angle. So therefore, we would write therefore like this: triangle ABE is congruent to triangle CBD. Now the only one piece of information that I've forgotten to put in is that we would need to write angle, angle, side. That would be the reason why we can say finally that these two triangles are congruent. So go back, write down the steps, write down this example, and we're going to do lots more in class. Next lesson that I see you on this, we'll be looking at similarity. Now, hope you've enjoyed the video, and I will see you all in class.